So the question becomes, of course, with performance is that can we train for this type of ankle stiffness to occur?
You know, there's a lot of evidence, right? That suggests when we're talking about stiffness that there are, many factors that relate to the stiffness, right? Even in a transient way. So there's the overall, if we're thinking about Hooke's law and stress strain curves and so forth, right? Any
Mhm.
any type of tissue, has its ability to deform or not, based on its physical properties, right? Um, so that could be something from a muscle contraction or jumping off of a box or whatever the case may be, but the transient stiffness of a tissue can change, depending on, many, many factors. But there is good solid research that shows that, stretch, shorten cycle types of activities, plyometrics, bounding, those types of activities, do change the long-term, characteristic of that tissue. So I would suggest, that the answer is yes, that if we are working on those types of activities, that the physical properties of that tissue, the stiffness of tissue can change with training.
That's something that we look into as well. And it's very fascinating because the fascia tissue around the ankle, there's the retinaculum. And the
Mhm.
retinaculum actually has 10 times more hyaluronic acid than the average fascia tissue in the body. So
Mhm.
it's the area that has a lot of these molecules. And also what is important to understand is that when we train for ankle stiffness, there is a different cell in the fascia, which is called myofibroblast. Now,
Mhm.
this type of cell is twice as strong as the normal fibroblast cells, but also it can contract. And
Mhm.
this also it increases stiffness. So what we believe is if we can actually increase the mechanical tension around the ankle and produce more of these type of myofibroblast cells, then we can actually increase the ankle stiffness.